Hello, all. Welcome to the day 54 of the daily case study series for CBSE Grade 12. The question goes like this: a manufacturer produces two models of bikes, Model X and Model Y. Model X takes 6 man hours work to make per unit. Model Y takes 10 man hours work to make per unit. There are total of 450 man hours available per week. Handling and marketing costs are rupees 2000 and rupees 1000 per unit for Model X and Model Y respectively. The total funds available for these purposes are 80,000 per week. Profits per unit for Model X and Y are rupees 1000 and 500 respectively. Based on the above details, answer the following questions. First question: formulate the objective of the LPP mentioned above. Let's write all this information given in the form of a table. 1 unit of Model X be represented as letter X. 1 unit of Model Y be represented as Y. If this X and Y notation is confusing, take P and Q. Model X, Model Y. And the parameters are hours, handling and marketing costs, then profit for each model per unit. Coming to hours, it is 6 man hours for Model X per unit, and it is 10 for Model Y per unit. Handling and marketing cost for Model X per unit is rupees 2000 and it is 1000 for Model Y. Profit per unit for Model X is 1000, Model Y is 500. The next column I bring it as total resource. Total of 450 man hours is available per week. And then rupees 80,000 is the max allowance for handling and marketing costs. Combined profit is 1000x plus 500y. So our intention is to maximize this profit given some constraints. The first constraint is with regard to the hours, that is 6x plus 10y has to be less than or equal to 450 hours because the total hours available is only 450. So this cannot exceed 450. So that is the first constraint. Second one, based on the handling and marketing cost. 2000x plus 1000y. This cannot exceed 80,000 because 80,000 is the fund available for handling and marketing cost. The other two are x greater than or equal to 0, y greater than or equal to 0. There is a scope of reducing the inequalities. So the first inequality, after we reduce, we get 3x plus 5y less than or equal to 225. Same way, after reducing the second inequality, we get 2x plus y is less than or equal to 80. So the LPP is maximize z equal to 1000x plus 500y subject to constraints 3x plus 5y less than or equal to 225, 2x plus y less than or equal to 80, x greater than or equal to 0, y greater than or equal to 0. This is the answer for 1 and 2. The third question, How many bikes of each model should the manufacturer produce so as to yield a maximum profit? Find the maximum profit. To do this, we have to convert all the linear inequality constraints to linear equations, plot them, get the feasible region, get the corner points of the feasible region, substitute those corner points into Z, and then figure out which is giving us a maximum return. So from which we can get the number of model X bikes and number of model Y bikes. Let's write all the linear inequalities as linear equations. That is 3x plus 5y is equal to 225. 2x plus y equal to 80. X equal to 0, y equal to 0. X equal to 0 represents the y-axis, y equal to 0 represents the x-axis. Coming to the first equation, 3x plus 5y is equal to 225. Making x as 0, we get y as 45. And making y as 0, we get 75 for x. For the second equation, 2x plus y equal to 80. Making x as 0, we get 80 for y. Making y as 0, we get 40 for y. Let's plot these two lines on the graph. This is a rough sketch of a graph. 0, 45 is somewhere here. Then 75, comma 0. So this line represents the equation 3x plus 5y equal to 225. The next one is 0, 80, then 40 comma 0. This line represents the equation 2x plus y equal to 80. The feasible region is this. The corner points can be named as O, which is the origin, 40 comma 0 is A, and we have to find the coordinates for B, and C is 0 comma 45. To get the coordinates of B, we need to solve these two equations. 3x plus 5y is 225, and the second equation is 2x plus y equal to 80. Multiplying the second equation by 5, 10x plus 5y equal to 400. Let's name this as 3. Now 1 minus 3, equation 1 minus equation 3 gives minus 7x equal to minus 175. X becomes 25. Putting this x equal to 25 in any one of these equations, we get y as 30. So the coordinates of B are 25 comma 30. So the feasible region is O, A, B, C. Now let's evaluate the value of Z at all the corner points. The corner points are origin 0 comma 0, A 40 comma 0, B 25 comma 30, C 0 comma 45. The value of Z at these points are, for 0 comma 0 we get 0, for 40 comma 0 we get 40,000. For 25, 30, again we will get 40,000. And for 0, 45, we get 22,500. We get two maximum at 40, 0 and at 25, 30. If we consider at 40, 0, which means that number of model X bikes is 40 and number of model Y bikes is 0, but the manufacturer is producing both the bikes, so we can't consider the maximum 40,000 at 40, 0. So the next one is maximum same 40,000 at 25, 30, which means to attain a maximum profit of 40,000, the manufacturer has to produce 25 model X and 30 model Y. Maximum profit is rupees 40,000, for which manufacturer has to produce 25 model X bikes and 30 model Y bikes. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.